Deepcool is the first to offer highly affordable ATX version 3.1 PSUs through its PLD series. I have already evaluated the 800, 750 and 650 watt models, and they all perform decently given their price tags. It is not easy for an older design to output 200% of its maximum power to be compatible with the requirements of the PCI Express 5.1 CEM, but Heli technology achieved that. The PLD line consists of 4 members with capacities ranging from 550 to 800 watt. In this review, I will evaluate the smallest member of the line. The box is plain, but it does its job well in protecting the PSU effectively. This is the typical Deepcool PSU design with a weird-looking fan grille with large openings allowing for good airflow. The PSU's dimensions are compact thanks to the 140mm length. At its front side, the exhaust grille has rectangle perforations instead of the typical honeycomb style ones, and the power switch has a distinctive color. Around the back, the flat native cables leave the PSU from a relatively small hole. The hole doesn't have a plastic grommet, but its edges are rounded and not sharp, so they won't damage the cables. The number of cables and connectors is sufficient for the PSU's category. The EPS cable is extra long and the ATX cable is long enough for a low capacity PSU, which will be primarily housed in small and medium-sized chassis. The 12+2 pin PCI Express cable is set at 600 watt, which is insane given that the PSU's maximum power is 550 watt. According to Intel's guidelines, it should be set at 300 watt. The distance between the peripheral connectors is short at 105mm, probably because each of the respective cables has 5 connectors, so the voltage drops on the last connectors would be increased with a longer distance. The OEM is Heli Technology, which is starting to impact the PSU market by collaborating with more brands. It is good to see more factories and OEMs entering the game since they can lower the prices. This older design uses a double forward topology on the primary side, which was popular several years ago, when most PSUs were bronze rated. Despite the budget price, the PCB is double-sided, which is a pleasant surprise. The soldering quality is good, and the parts that Heli used do not belong to top-tier manufacturers to keep the production cost under tight control. The bulk cap is by Zheng X, which belongs to the Chinese government, hence it has enough money to spend on equipment, and the electrolytic caps on the secondary side are by the same manufacturer. 9 polymer caps are also used for ripple filtering. On the secondary side, a synchronous rectification scheme is used with 2 FETs handling the 12-volt rail and a pair of DC-DC converters generating the minor rails. For last, I left the cooling fan, provided by an unknown brand, at least to me. It is supposed to have a hydraulic dynamic bearing, but since this is the most expensive bearing, I highly doubt about that. The 12-volt rails over current protection is set above 130% because this low capacity unit has to cope with increased power spikes that last long. Overcurrent protection on the same rail drops at around 139% under hot conditions. We have a paradox at overpower protection. Usually the triggering point should be lower under high temperatures, but in this unit the opposite applies. Heli should fix that. The same was the case in the 650 watt unit. The overcurrent protection triggering points are set high on the minor rails and the triggering points are close between cold and hot conditions, which does not effectively protect the PSU. Load regulation is within 1% on the primary rails. Ripple suppression is good. The transient response is mediocre overall. Heli should improve the 3.3 volt rail's terrible transient response. Given the platform's age and price, the 12 volt rail keeps its voltage at a satisfactory level. The PSU passes all ATX version 3.1 transient response tests. The 3.3 volt rail also keeps its voltage well above 3.2 volt. So far, only the 800 watt model drops its 3.3 volt rail below 3.2 volts. Efficiency is low in all ranges and the PSU doesn't achieve over 70% efficiency with a 2% load. It also doesn't pass 60%, which the ATX spec requires. This means the PSU doesn't meet the corresponding ATX version 3.1 specification requirement. I will ask Deepcool to send me another sample for retesting, since it is a great shame to be cut in this test while it passes the challenging transient response test. The platform's average efficiency is low, especially at 150 volt. The EPFC converter needs tuning for higher performance, primarily at 230 volt. The 5 USB rail is highly efficient. Vampire power is low. The average noise output is high considering its capacity. We should also consider, though, the platform's not so high efficiency, which increases the thermal loads. Hence, the cooling fan has to work more to remove the heat. Fan noise and speed maps. There is no semi-passive operation and the fan starts at high speeds above 1000 RPM, so noise output is within 20 to 25 decibels from the start. At around 350 watt at 12 volt, the 30 decibels mark is passed, and with more than 405 watt, noise exceeds 35 decibels. Even in the worst case scenario, noise is within the 35 to 40 decibels range. The PSU achieves a higher overall performance than the PN550D, which uses a more modern platform. Since I only had two 550 watt PSUs meeting the ATX version 3.1 transient response tests in my database, I had to include in the graph several 650 watt units. The PLD series is the first to bring highly affordable ATX version 3.1 PSUs to the masses using an older Heli platform with a double forward topology, which was popular several years ago when most PSUs were bronze rated. With today's standards, bronze and silver efficiency levels are low, with many gold units sold at reasonable prices and available from various brands and manufacturers. The problem is that ATX version 3.x compatibility still costs a premium, so it is nice to see budget ATX version 3.1 units offered by big brand, since this will push other brands to follow this path. To keep the cost down, the PLD units don't have any modular cables, which are very helpful during the system's setup. The soldering quality is good on the internals, but the parts are not from known manufacturers to save money. Still, Deepcool seems to believe in this platform's reliability, otherwise it wouldn't support it with a 5-year warranty. The PL550D passes the strict ATX version 3.1 transient response tests, which apply up to 200% of the PSU's maximum power loads, but it fails to meet the above 60% efficiency requirements, meaning that it cannot get an ATX version 3.1 badge. I asked Deepcool to fix that and sent 2 samples for the testing. Moreover, given the lower than 17 milliseconds hold-up time, this unit cannot get an ATX version 3.0 badge either, since this specification requires at least 17 milliseconds of hold-up time, a requirement that was loosened up in the ATX version 3.1 spec, which only asks for 12 milliseconds hold-up time. The 600 watt setting of the PSU's 12+2 pin connector is insane, given that the unit's maximum power is 550 watt. Regarding performance, load regulation is tight on all rails, since the PSU's low capacity and the native cables help there. Ripple suppression is good, and the 12 volt rail keeps its voltage at a reasonable level under increased transient loads. Because of the outdated design, the average efficiency is not high, but the unit still achieves a Cybernetics Silver efficiency rating. I couldn't find the US price, but Deepcool mentions a 49 euros price tag in Europe, which is low even for a plain 550 watt unit. A note about the Cheng X capacitors on these units' primary and secondary sides: you should not be afraid of them. The quality and performance of the Chinese caps have been tremendously improved in the last few years. Cheng X also makes caps for several big names in the industry, including known Japanese capacitor brands. Look at my evaluation tests if you want facts and not just rumors about capacitor performance. Another thing I want to mention here is the ATX spec that this unit is compliant with. Although Deepcool mentions ATX version 3.0 since it uses native cables, it can automatically meet the ATX version 3.1 requirement if they fix the platform to achieve over 60% efficiency with a 2% load. There is no change in the 12V HPWR or 12V 2x6 cable. Only the 12 plus 4 pin headers are changed on PSUs that have them on their modular panels and the graphics cards. This means that PSUs using a pair of 8 pin sockets or the ones with native cables which already meet the ATX version 3.0 requirements are automatically upgraded to ATX version 3.1. I already talked to Deepcool about that, and they told me that the marketing material and badges will have the ATX version 3.1 badge in the next production batch. They should also use the corresponding cybernetics badges. Before investing in a new power supply, read my best ATX version 3.1 PSUs article on hwbusters.com to check all alternative PSU offerings. You can find the review of the PL550D also on the same site. Bye bye.